Welcome to our today's lesson, and I'm starting a new topic with you. The topic is pressure. You may have not studied this topic before, but the term pressure is not a new word to you. We've had pressure. You've mentioned pressure with your friends. Your friends have given you pressure, and you know how. Your parents at some point have given you pressure, and also you have given your parents pressure at some point. But now, let's look at this pressure in a different dimension. You know, when somebody places his or her hand on you, you will feel the pressure. So that is the kind of pressure I would like us to discuss today. When you wear a heeled stiletto shoes, the sharp pointed ones, and you walk, I think walk is the best term I can use, on a soft ground, you will leave some marks. Why? Because you are applying pressure on it. When you walk on a sandy soil in the beach, your legs, depending on how flat they are or how sharp they are, can leave some marks because of pressure. And you will realize that the sharp the object is, the higher the mark it will leave. So all this is pressure. There are two categories of pressure we are going to discuss today. Pressure in solids and pressure in liquids. But I'm going to start with pressure in solids. But first we need to define what is pressure. Yes, we've had pressure a long time ago, but what is pressure? Pressure is also a derived quantity, which we derive it from force and area. Now, let's get here. Pressure is the force acting perpendicularly per unit area. Force acting perpendicularly per unit area. Or force acting normally per unit area. The word perpendicularly can be replaced by a word normally. Normally means it acts on it at an angle that is 90 degrees towards it. Not on sideways. It acts on it normally. Now, because we have used two words there, we have used force and we have used area. Force, we know its units, the newtons. Area, we know it's a derived quantity of length. Its units is meter square. Now, force acting normally per unit area. So for you to get pressure, we can even use the definition of pressure to get how we work out pressure. Force acting normally per unit area. Per unit area. So we take force, we divide it by area. We get pressure. So in short, pressure is given by force over area. I want us to derive the units of pressure using the formula. Force, which is newtons. Area, which is meter square. The units for pressure will be Newton per meter square. For example, you have a force of 20 newtons and you have an area of conduct 5 meters square. 20 over 5. 20 newtons over 5 meters square. You will get 4 Newton per meter square. So Newton per meter square, as I have just displayed on the board to you, is the unit for pressure. Also, 1 Newton per meter square is the same as Pascal. Pascal is denoted by PA. Pascal is the person who worked out this about pressure, and he gave the unit as Pascal or Newton per meter square. Any of the two is correct. So 1 Newton per meter square is the same as 1 Pascal. Now, pressure is given by force over area, which is F over A, if we have to use the notion. If you have to get F, you make F the subject of the formula. So force, which is F, would be pressure times area. And area would be given by force over pressure. So when given 2, ensure you can get the other 1. For example, if you have F and A, you can get P. That is the pressure. If you have P and F, you can get A. And when you have P and A, you can get F. Don't just fix yourself on calculating pressure alone. We can give you pressure and area. Give us the force. Before we look at some of the examples here, I want you to get this. Sometimes we give you weight. So weight is the force, actually. Don't say we don't have force. Weight is the force. And in most cases also, we don't give you the weight directly. We give you the mass. In our previous lesson on force, I told you how we can convert mass to weight. We multiply by the gravitational field strength. So be aware of such concepts. Yes. Another concept which I will show you right now, as I have displayed on the screen, is if pressure is given by force over area. So area is the denominator. It is the determining factor, actually. If you increase the cross-section area, I mean the area of contact, that is, you are reducing the pressure. The area of contact determines whether the pressure will be high or low. If you increase the area of contact, you will reduce the pressure. I've given you 3 there. So the normal one, pressure is given by force over the area of contact. Force is the weight of the solid, that is. Minimum area gives you maximum pressure, and maximum area gives you minimum pressure. We will do such examples. So if they ask you, calculate the maximum pressure, use the minimum area. That's what you need to get. Use the minimum area. That's what I've also told you. Now, we have 2 factors affecting pressure in solids: weight of the solid and area of contact of the solid with the surface. An increase in weight increases the pressure. A decrease in weight decreases the pressure. For area, it's a vice versa. When you increase the area of contact with the surface the solid has, when you increase, you are reducing the pressure. And when you reduce the area of contact with the surface, you are increasing the pressure. Look at this example. I want us to follow it keenly. A block of a soapstone of dimension 4 meters by 2 meters by 3 meters is 48 kilogram and is made to rest on a smooth horizontal surface. Is made to rest on a smooth horizontal surface. So we have the dimensions 4 by 2 by 3, and then we have the mass. So we have to calculate the maximum pressure and the minimum pressure it exerts on the surface. Let's start with the minimum pressure. First of all, what is the weight? The weight is 48 kg times 10. We get 480 newtons. That is the weight, which is the force. For us to get the minimum pressure, we need the maximum area of contact. And when you see the dimensions given there, we have 4 by 2 by 3. So we can get 3 areas there that the solid can be in contact with the surface. We can get 4 by 2, 4 by 3, and 2 by 3. And because we are looking for the minimum pressure, we are going for the maximum area, which is 4 by 3. So 4 by 3 will give us 12 meters square. And the force we have said, it is 480. So our minimum pressure will be 480 divided by 12. You will get it. Maximum pressure it exerts on the surface. Now, the maximum pressure will be given by the force, which is 480, or the weight, over the minimum area, which is 2 by 3. So 480, you divide by 6. That is how it should be. Yes. That's how it should be, and that's how it is. Even the workings there is just like I've done it. Now look at this. Look at this. An object whose area of contact with the flow is 5 meters square exerts a pressure of 900 Pascal. Calculate its mass. The keyword is mass, not weight. You know, most of you will forget it and they end up in force, which is the weight. But you know, they're talking of the mass, so you may end up missing the point. But now listen. 900 pascals means 900 Newton per meter square. So this 900 is given by force over area, or weight over area, which we don't know. So 900 is equal to F over 5. So our F is 900 times 5, which we will get 4,500 newtons. The question is mass. Divide by 10, get 450 kg. That is it. And that is how it should be done. An explanation question here, which I will explain to you. Then I add you more explanation questions on the same. Trucks. Understand this. I'm not talking of medicine. I'm saying trucks which carry heavy loads have many wheels. Explain. Trucks which carry heavy loads have many wheels. I think you've seen this. Yes. I have a friend of mine, Kipchumba. Kipchumba saw the first lorry that has 22 wheels when he was joining university. So we have many Kipchumbas outside there, but just get it from me that we have some very, can I say long or tall? Long trucks. So they need many wheels. You know, the other vehicles, the saloon cars just have 4. No need for many because it is, or they are light. Now, these trucks that have many wheels, the many wheels increase the area of contact with the ground, thereby reducing pressure exerted on the road. This prevents the damage of the roads by trucks. Apart from avoiding damage on or preventing damage on the roads, it also avoids or prevents the tires from bursting because the pressure exerted by the heavy lorry is distributed to the very many wheels. That is the point. Now, somebody will ask you a question. Somebody will ask you a question. You know, you've seen an elephant. If you have not, please make an assumption that you've seen it, even if it is in a TV or in a book. Elephant is one of the biggest animal. And when walking on a sandy surface, you will not see the feet of the elephant. But when a young girl walking on the sand, you will see the feet. Yet, the elephant is many times heavier than this boy. Now, the difference is because elephant's feet have a greater area of contact with the ground. So, yes, the elephant is heavy, but the feet are also very large. They have a large area of contact. So, less pressure is exerted by the elephant onto the ground. That's another good example you can use. Look at a block of copper of density 9 grams per centimeters cubic measures 5 by 3 by 2 centimeters. Given that the gravitational field strength is 10 Newton per kg, find or determine the maximum pressure and the minimum pressure, of course. Now, starting with the maximum pressure, first of all, for you to get pressure, you require the weight, that is the force, and the area. So we have the areas because we are given the dimensions. But now, we don't have the weight that comes from the mass. So we have to go ahead and calculate what? the mass. So first of all, we are told that the density is 9 grams per centimeters cubic. And the volume, of course, is given from the diagram. You can find it 5 times 3 times 2. You get that centimeters cubic. Mass is given by volume times density, which is now, if you have to get it, what will you get? 270 grams. Now, divide by 1,000 to get kilogram, then multiply by 10 to get newtons. You will get 2.7 newtons. After getting 2.7 newtons, now, for you to get maximum pressure, use the minimum area, which is 3 times 2. And now, these areas are in centimeters, but we cannot work out with centimeters. What do you do? What do you do? What do you have to do? You have two options. Either, first of all, calculate the area in centimeters square, then divide by 10,000. Or you give the values, first of all, in meters, 0.03 meters, 0.02 meters. Then you get the area. I find it easier. Just get the area in centimeters square, then simply divide by 10,000. 6 divide by 10,000, you will get 0.0006 meters square. Then 2.7 divide by now the minimum area, which is 0.0006. You will get 4,500 Newton per meter square. The other one is minimum pressure. We will still use the same weight, which is 2.7. And then we divide by the maximum area, which is 5 times 3, which is 15. Convert it to a meter square. You divide by 10,000, 0.0015. You get 1,800 Newton per meter square. That is it. That is how you are supposed to do it. Another question is there. It is painful if one tries to lift a heavy load by a thin string. It is painful if one tries to lift a heavy load by a thin string. How do you explain that? When you carry, I've seen some people when you try to carry maybe a bucket of water with that wire as the holder, you pick your handkerchief and then you lift it. But for the boys without handkerchief, they pick some leaves they use to hold it so that they don't feel the pain. It's all about pressure. The thin string applies a greater pressure because the area of contact between the string and your hand is so small, so it will apply a greater pressure to your hand. That's why you are feeling the pain. So there is a small area of contact with the fingers when a thin string is used. As a result, more pressure is generated, and this is painful. Yes. So there's some exercise here. I've just displayed for you. Then later on, I will give you their answers, but just to work on them, let me just display it. Starting from the question 1 is here. There is something missing in question 1. Just start from question 2. A thumb is used to push a thumb pin into a piece of wood. Explain in terms of pressure why the pressure on wood is greater than the pressure on the thumb. An elephant of mass 28 kg has a feet of average area of 200 centimeters square. A vulture of mass 12 kg walks beside the elephant on a muddy area. The average area of the feet of the vulture is 2 centimeters square. Which one is likely to sink? Explain your answer, showing any necessary calculations. Yes. A girl standing upright exerts a pressure of 1,500 Newton per meter square on the floor. Given that the total area of contact of shoes and the floor is 0.02 meters square, find the mass of the girl. Determine the pressure she would exert on the floor if she stood on 1 foot. Very nice question there. A block of copper of density 8.9 grams per centimeters cubic measures 10.6 by 4 centimeters. Given that the force of gravity is 10 Newton per kg, determine the maximum pressure, the minimum pressure that it can exert on the horizontal surface. So that's what it is in pressure in solids. Get it very well.